To correctly size the electric heating service for an assisted living facility, it is essential to adhere to the National Electrical Code, specifically Article 220.82. This section provides guidelines for calculating the demand load for electric heating in dwelling units, which is applicable to your situation involving 63 living units, each equipped with electric heating and cooling. The key is to understand how to apply the demand factors outlined in the NEC to determine the minimum required service capacity. In your scenario, the total connected load for the electric heating equipment is 1448 amps 3-phase at 208 volts single-phase. Article 220.82c6 allows for a demand factor of 40% to be applied to the total connected load of electric heating. This means that you don't need to size the service for the full 1448 amps. Instead, you calculate 40% of that value. The calculation is as follows: 1448 amps multiplied by 0.40 equals 579.2 amps. This is the calculated demand load for the electric heating service. However, it is crucial to ensure that the service is sized appropriately for the actual load it will carry. The NEC mandates that the service be sized no smaller than the calculated load. Since standard electrical equipment is available in specific capacity ratings, you must select the next higher standard size. In this instance, the calculated load of 579.2 amps falls between standard sizes. The next standard capacity above 579.2 amps is 600 amps. Therefore, the electric heating service should be rated for 600 amps at 208 volts, single phase. This means the overcurrent protection, conductors, and all related equipment must be rated to handle at least 600 amps continuously. It's also important to verify that the selected conductors are suitable for the calculated load and the ambient temperature conditions. The conductor capacity must be sufficient to carry the 579.2 amps demand load, considering any applicable directing factors for ambient temperature or the number of conductors in a raceway. Consult NEC Table 310.15b16 and other relevant tables for conductor capacity ratings and directing factors. Furthermore, the overcurrent protection device, such as a circuit breaker or fuses, must be sized to protect the conductors. The overcurrent protection device should be rated no higher than the capacity of the conductors it protects, as per NEC 240.4. This ensures that the conductors are protected from overloads and short circuits. The 600 amp service requires careful coordination with the utility company to ensure that their infrastructure can support the additional load. Coordination involves informing the utility of the new service size and obtaining their approval. The utility may have specific requirements for the service entrance equipment and metering. You should also consider the voltage drop in the service conductors. Excessive voltage drop can negatively impact the performance of the heating equipment. The NEC recommends limiting voltage drop to no more than 3% for feeders and 5% for branch circuits. To minimize voltage drop, select conductors with sufficient size and keep the conductor runs as short as possible. Grounding and bonding are critical for safety and proper operation of the electrical system. Ensure that the service is properly grounded and that all metallic components are bonded together to create a low impedance path for fault currents. Refer to NEC Article 250 for detailed requirements on grounding and bonding. In addition to the electric heating load, the facility has another electrical service for the rest of the building. It's important to ensure that both services are properly coordinated and that the total load on the utility system is within acceptable limits. This may involve performing a load study to determine the peak demand of the entire facility. Remember, this explanation is based on the information provided and the NEC. Local codes and regulations may have additional requirements. Always consult with a qualified electrical engineer and the local electrical inspector to ensure compliance with all applicable codes and standards. Failing to follow the NEC can result in safety hazards, equipment damage, and code violations. Consider future expansion. Will the assisted living facility add more units or additional loads that are not included in your calculations? If so, The electrical system may need to be sized to handle those future loads. The goal is to not undersize the system to avoid unnecessary costs. Oversizing the system will not hurt anything. The calculated load of 579.2 amps is a minimum value. Increasing the service size to allow for expansion will help avoid the costly expense of replacing it later. In summary, the steps to size the electrical service are as follows. Firstly, determine the total connected load of the electric heating system, which is 1448 amps. Secondly, apply the demand factor for NEC Article 220.82C6, which is 40%. Thirdly, calculate the demand load, which equals 579.2 amps. Fourthly, select the next standard ampacity, which is 600 amps. Fifthly, ensure conductors, overcurrent protection, and equipment are rated for 600 amps. Sixthly, coordinate with the utility company. Seventhly, verify grounding and bonding. Eighthly, consider future expansion. And ninthly, consult with a qualified electrical engineer and local electrical inspector. The 600 amp service will supply the electric heating and cooling units in the assisted living facility. All 63 units will be connected to this service. Each unit will draw power from the service as needed to maintain the desired temperature. The actual load on the service will vary depending on the time of year, the weather conditions, and the thermostat settings in each unit. During peak heating or cooling seasons, the load on the service will be higher. During milder weather, the load will be lower. The demand factor of 40% accounts for the fact that not all units will be operating at full capacity simultaneously. It is unlikely that all 63 units will be heating or cooling at the same time. The demand factor is based on statistical data and experience with similar types of installations. By applying the demand factor, the service can be sized more efficiently without being unnecessarily oversized. However, it is important to monitor the actual load on the service to ensure that it does not exceed the calculated demand load. If the actual load consistently exceeds the calculated demand load, it may be necessary to increase the service size. Installing a monitoring system to track the load on the service is always a good practice. This system can provide valuable data for optimizing the electrical system and identifying potential problems. The electric heating and cooling units in the assisted living facility will typically be controlled by individual thermostats in each unit. These thermostats will automatically turn the heating or cooling equipment on and off to maintain the desired temperature. The thermostats may also have additional features such as programmable schedules and energy-saving modes. The efficiency of the heating and cooling equipment can significantly impact the energy consumption of the facility. High-efficiency equipment will use less energy to provide the same amount of heating or cooling. It is important to select energy-efficient equipment to minimize operating costs and reduce the environmental impact of the facility. Regular maintenance of the heating and cooling equipment is also essential for maintaining its efficiency. Dirty filters, clogged coils, and other maintenance issues can reduce the efficiency of the equipment and increase energy consumption. Implementing a preventative maintenance program can help to ensure that the equipment operates at peak efficiency. The electric heating and cooling equipment will typically be connected to the electrical service through branch circuits. These branch circuits must be sized according to the NEC to ensure that they can safely carry the load. The size of the branch circuit conductors will depend on the ampacity of the heating and cooling equipment. The overcurrent protection device for the branch circuit must also be sized appropriately to protect the conductors. Ground fault circuit interrupter protection may be required for certain branch circuits, such as those serving bathrooms or kitchens. GFCI protection is designed to protect people from electric shock. Surge protection is another important consideration for the electrical system. Surges can damage sensitive electronic equipment, such as computers, televisions, and appliances. Surge protection devices can help to protect this equipment from damage. Surge protection can be provided at the service entrance and at individual branch circuits. Power quality is also important for the proper operation of the electrical system. Power quality refers to the stability and cleanliness of the electrical power. Poor power quality can cause equipment malfunctions, data loss, and other problems. Power quality problems can be caused by a variety of factors such as voltage sags, voltage swells, and harmonics. Power quality problems can be mitigated by installing power conditioning equipment such as surge suppressors, voltage regulators, and harmonic filters. Finally, safety is always the top priority when working with electrical systems. Only qualified electricians should perform electrical work. Always follow safe work practices and use appropriate personal protective equipment to energize the circuit before working on it. Test the circuit to make sure it is energized. Use insulated tools. Wear safety glasses. Electrical accidents can be serious or even fatal. Taking the necessary precautions can help to prevent accidents. The electrical service for the assisted living facility must comply with all applicable codes and regulations. These codes and regulations are designed to ensure the safety and reliability of the electrical system. The NEC is the primary code used in the United States. However, local codes may also apply. The local electrical inspector is responsible for enforcing these codes and regulations. The electrical inspector will review the electrical plans and inspect the electrical installation to ensure that it complies with the codes. It is important to work closely with the electrical inspector throughout the project to ensure that the electrical system is installed correctly. The information provided is for general guidance only. It is not a substitute for professional advice. Always consult with a qualified electrical engineer and the local electrical inspector before designing or installing an electrical system. Electrical systems can be dangerous. If you are not qualified, do not attempt to work on them. Hire a qualified electrician to do the work for you.